So here we are. We are finally at linear and quadratic functions. So we're going to graph not only linear equations, which we should be pretty good at this point, but we're going to start to graph quadratic functions. So graph of a function, let's get our pen correct. Graph of a function, graph of an equation that defines a function. So these are solutions to an equation, typically with two variables, x and y, or x and f of x if it's a function. So we are actually going to have functions. So we'll see f of x, which we know is the same thing as y equals mx plus b. It's just taking place of my y variable or my vertical axis. Quadratic has a squared value, parabola. Parabola has the shape of a U, and it has an axis of symmetry, which is very important. It has either a max point or a min. When a is greater than 1, it's going to have a U. When a is less than 1, it's going to have an upside down U. So that's a max point. This is a minimum point. Let's see what else they have for us. Axis of symmetry, yep. If we want to find the axis of symmetry, this formula is going to be very important. And the vertex, that helps us. Axis of symmetry gives us the symmetrical center. And then we can find the vertex, which is either going to be the minimum or the maximum. If we plug in, we know that the min or the max will lie on this axis of symmetry. So we'll plug in that x value, and it'll give us the y value or the f of x value. Good. So let's get going. So notice that they show that those are the same things. It has a y-intercept of 2, a slope of -1, and bang, bang, we can graph them. We don't really need to do a table. If you need to, by all means, but we're sophisticated enough in Chapter 8 where we don't have to do that. So we know that this is written g of x equals x minus 2, or we can write the equation y equals x minus 2 with a slope of 1 and a y-intercept of -2. So we'll go down 2, make a dot, use a slope of 1 over 1, 1 over 1. We'll make a couple dots. We will connect those dots, and we will put arrows in order to indicate that those solutions go on forever. There are an infinite number of solutions, and that's our graph for the line. Draw a graph of each linear you may wish to verify. We don't want to verify, not linear equations at least. So this has a slope of -1 and a y-intercept of 3. So we start on the y-axis. We could find out where it is 3. And then we use the slope. Slope is -1 over 1 as a fraction. That's down 1, right 1. So down 1, right 1, make a dot. Down 1, right 1, make a dot. And we will connect those lines. Whoops. Some teachers, excuse me. Some teachers want you to label points. When you label points, you want to put it next to the point. So that would be 0, 3. This would be 1, 2. And this would be 2, 1. So labeling points are good, not necessary, depending on the teacher. So we want to see this. This is function notation, but I'm going to write it with the variable first. So now I can see what my slope is. My slope is -1 over 2. My y-intercept is 2. So 2, down 1, right 2, down 1, right 2. Connect the dots. Arrows. And that shows all of the solutions. So yeah, that's going to be a better, yep, that's good. So that's going to show all the solutions to this function. This is a good one. So my slope equals -2/3, and my y-intercept is going to be 0. So I make a dot at 0. I go down 2, right 3, down 2, right 3, or I can go up 2, left 3. So I put the negative in the denominator instead of the numerator. It doesn't matter. Both are correct forms. They are equivalent, and that's the important thing for us to know. We know that they are equivalent fractions, so they would be equivalent slopes. That -2/3 is the same as 2 over -3, which is the same as -2/3. I like this one also. Good, they've got some good. So this has a slope of 0, not no slope. It has a slope of 0 and a y-intercept of -4. 0 is a fraction, is 0 over 1. So -4, 1, 2, 3, 4. I'm going to go down 0, right 1, down 0, right 1. So I have a horizontal line. And that makes sense because remember, when you only have one variable, and in this case we have just y, it's going to cross the y-axis at -4, and it'll be a horizontal line. So that would be the graph of that one. Same thing here. We have a slope of 0 because think about this. This is n of x equals 0, x plus 5. So my slope is 0. My y-intercept is 5. A lot of students think that 5 represents the slope. Not the case. Slope is always going to be the coefficient of x. So 5, 1, 2, 3, 4, 5, and it can go this way also. It doesn't matter which way it goes, but we're doing horizontal line, or horizontal. Whoa, let's clean that up a little bit. Better. Arrows and points if you need points. All right, parabola. So there's a couple of ways of doing parabolas. We like the fact that a parabola we know is symmetrical, but we don't know where that is. We can have a graph here, and you can have points like this, and it looks, if you plot 1, 2, and 3, you'll get this shape. That kind of looks like it's linear if you didn't know better. But if you extend it and you keep going, you see that the turn is down here. So it's kind of hard to know where the turn is. You can't really tell what the shape of the parabola. Parabola could have gone this way either. Also, you don't know. So it's very important to find the axis of symmetry. It's very simple to find the axis of symmetry. You find it by plugging in the opposite of b over 2a will give you your x value, this axis. It will tell you where along the x-axis that vertex is. This is the x value. That's the x value to the vertex. I think I need to get a better pen. Good. So that's why we find that. Then we plug it in, and that'll produce our y location. So then we'll know where on the y-axis does my point exist, does my vertex. So this is called the vertex. This is called the axis of symmetry. We're also going to use the axis of symmetry in a number of other ways because we know points are equidistant. So if I find the y-intercept here, let's change that color. If I find the y-intercept, it's 1 away. I know its mirror point is going to be 1 away. If I find the x-intercept is 2 away, I know that its mirror point is going to be 2 away. So we use this axis of symmetry also to find its mirror points. It saves us from doing a lot of this graph work. So you'll see how I do this somewhat efficiently. So first thing we always need to do is we need to put it in slope-intercept form. So that's negative x squared, technically plus x plus 2, and my a value is going to be negative 1. That means my parabola is going to go upside down. What a way to start. And my b value is 0, and my c value is 2. So remember, the axis of symmetry is what I want to find first, of symmetry. So x equals the opposite of b over 2a, so that's negative 0 over 2 times negative 1, which ends up being 0. So what I just learned was that my axis of symmetry, let's make it skinny, my axis of symmetry is going to be on the y-axis. So that kind of helps me, doesn't help me. I'll show you where it helps me and where it doesn't. So some other things that we know. Some other things we know is that this is the y-intercept. So I know one point is going to be at 2. Now, I can't use the symmetry because it lies on it. So its distance is 0 from the axis of symmetry. So yeah, I might have to plug some points at this juncture. That's the unfortunate component of this exact graph. So we have this, we'll do an h graph, we'll do x, we'll say y equals negative x squared plus 2. We won't do the b value. And then we'll plug some values in. So I don't have to do 0, I'm going to do 1. So y equals negative 1 squared plus 2. We're going to square 1 and then attach the negative. So that's negative 1 plus 2, so y equals 1. So I have a point 1, 1. So 1, 1. Now that is 1 away from the axis of symmetry, so I know its mirror point is 1 away. Does this shape, clearly it's going to be in this upside down, does that go with what I was expecting? Yeah, remember, when a is negative, I know it's going to be an upside down parabola. So let's find another point. Let's plug in, let's plug in 2. So y equals negative 2 squared plus 2. Y equals negative 4 plus 2. Y equals negative 2. So we have my second point, 2, negative 2, 2, 1, 2. And so it is 2 away on this y-axis. So I'm going to go 2 on the other direction. So I have 5 points. Typically, I only ask students to do 5 points. And now I have an excellent graph of the parabola for this. Let's do this. Let's take a peek at, because it said to use a graphing calculator. So let's use Desmos. And let's plug in this formula, y equals 2 minus x squared. And does that look like my points? 0, 2, and that's an interesting one. So I think I had the point here. I think I had, negative 2, 2, and then I had 2, negative 2. Yep. And then I knew my y-intercept was that. So that looks pretty good. That looks like my graph. Let's cut and paste and save it on the page underneath. Well, let's put it there. Let's do this. Let's do this. Let's shrink it. Let's put it maybe a little bit more shrinking. Yeah, so that's what we were expecting it to look like. Good. So we see the technique. So first step, step one is find the axis of symmetry. So axis of symmetry, x equals the opposite of b over 2a. So A is -2, B is, well, B is 0, C is also 0. So we'll use that piece of information because C is the y-intercept, but we won't use that just yet. That's 0 over 2 times -2, which equals 0. So my axis of symmetry again is on the y-axis. I know that my y-intercept is 0, so I make a dot. So that is going to be a maximum point. How did I know it was going to be maximum? Because my A is negative. So now we're done with that. There are no mirror points that I can plug in. So I will now find additional points. Additional points. Using the H chart, I'm going to plug in x. Y equals -2x squared. Y, we'll do this fast. Plug in 1. You get -2 times 1 squared, which is -2. So the point is 1 on the x, -2 on the y. It is 1 away from the axis of symmetry, so its mirror point is going to be 1 away. I'm going to plug in 2. Y equals -2 times 2 squared, which is 4, which is -8. So 2, -8 is here. That's 2 away. So I have the symmetrical. So this is what my parabola looks like. Pretty simple, pretty easy, right? I mean, we get 5 points. We get the freebie with the y-intercept. We have to create the 2 on the right side, but we get 2 freebie because of the understanding symmetry. So that's how I would advise you to be efficient with these. It's in slope-intercept form. So we are going to do axis of symmetry, axis of sim, opposite of B over 2A. B is -3. Notice I did the negative and then the B value. Over 2 and A is 1. So we get 3 halves. Now this is kind of fun because the axis of symmetry is 3 halves. So that's 1. So it's going to be between those whole numbers. Let's move it over a little bit. There you go. Now my so that's number 1. Number 2, my y-intercept. So now I'm going to use my y-intercept. My y-intercept, what's my c value? Is 0. So my y-intercept is 0. So I know that that is 1.5 away. So 1.5 the other direction is going to be that point. So this is where teachers want to see comprehension. They will ask you to label these points. That's 0, 0. That is 3, 0. Understanding that it's 1.5 away. So that's part 2, was I found a point and then I got the mirror point. So when that axis of symmetry is off of the y-axis, we get a free point with the y-intercept. Oh, I forgot to plug it in. Have I been doing the axis of symmetry? Knowing my vertex? Oh, I did know my, yeah. So, whoops. So let's find the vertex. That's what I should have done first. Sorry, this is 1A. Find the vertex. I didn't have to find the vertex before because it lay vertex. It lay on the y-axis, so I knew it was the y-intercept, so I could just derive that from the equation. So finding the vertex, I know the x value. I know that it's going to lie somewhere on here, so whatever that point is going to have an x value of 3 halves. So I'm going to plug that back into here. 3 halves squared minus 3 times 3 halves. So that is 9/4 minus 9 halves. Everybody good with their fractional work? Hopefully you are. So this is 9/4 minus 18/4. We need like denominators. And we get y equals -9/4, which I will turn into a whole number. So we have the fraction 3/2, comma, -2 and 1/4. So -2 and 1/4 takes us right about here. So that's my vertex. It doesn't have a mirror point because it lies on the axis of symmetry. And now I need to just find one more point. So 3 is find an additional point. An additional point. So what's going to be easy? We could do 1, but that's going to put it here. Let's do something outside of it. We can do 2. We can do -1. I'm going to do -1. So the equation is y equals x squared minus 3x. I'm going to use x equals -1 so I can have something outside here. I know it's going to be a u. So y equals the quantity -1 squared minus 3 times -1. That's 1 plus 3, which is 4. So my coordinate is going to be -1, 4. And this is where it gets somewhat tricky, not graphing 1, 4. So 1, 1, 2, 3, 4. That's easy. And that goes with the shape. That looks like it's a nice parabolic shape. But the hard part is finding its mirror is 1, 2.5. So that's a half, 1.5, 2.5. So that goes there. Look at that shape. That's so nice. Efficient. You still need arrows. So this is how you graph parabolas pretty fast. And then you get better at it. So you're constantly knowing what the axis of symmetry. You can do it really quickly. Opposite of B, all over 2a, which gives us 1 over -2. Now I'm going to find my, so I know my axis of symmetry is -1/2. Yuck. Let's move it. We can move it that way too. This time I'm going to find my vertex first instead of using the y-intercept. Sorry about that. Vertex. So we're going to take that and we're going to plug in -1/2. It's the opposite of -1/2 squared plus -1/2. That gives me y equals -1/4. -1/2 squared is 1/4. I bring down that negative. This makes -1/2. We're going to find common denominators, which is -2/4. So we get -3/4. So that's my vertex. I plugged in -1/2, and I got out -3/4. So now we got lots of fraction work right there. My y-intercept is 0, so I make a second dot there. It's a half over, so it's going to be there. That's not really fun values. So just because they're so tight and close. And now we're going to find another. One. Let's do this. Let's group. Let's make. Whoops, sorry. Let's make that smaller. Let's do this. And 3 is another point. Additional point. So what are we going to plug in? Let's plug in 1. So y equals the opposite of 1 squared minus 1, which equals 1 squared is 1. We bring down the negative. So y equals -2. Does that work? Did that make sense where we'd have 1, -2? No, it doesn't. So what mistake did Mr. Mac make? Well, I'll tell you what the mistake is. Look at A. I knew A was -1, so this parabola should be going in this form. So I clearly made a mistake somewhere. So where did I make the mistake? So the opposite of B. B is -1. Duh. So I'm doing all this work Wrong. Did you see that? Did you see that mistake that I made? So that's positive. So negative 1/2. So did I, the opposite of B. Oh no, that was correct. Excuse me. That was correct. I was okay with that. That's my B value. Opposite of B. B is 1. So negative 1. Oh, that's where I forgot. Negative. So the opposite of B. So that is actually 1/2. So, sorry. That's 1/2. Well, that value is going to be incorrect, maybe. So 1/2, yeah, because positive 1/2, positive 1/2. Well, let's erase all this, shall we? Mr. Mac. And my axis of symmetry is on the other side of the graph. This value is correct, however, which is the funny part. 1/2, 1/2. So 1/2 squared plus 1/2 is negative 1/2 plus 1/2, which is 0. So we get the point 1/2 0, 1/2 0. So it's right there. 0 on the y. We get the point is 1/2 0. What? It's Sunday. I'm making some silly mistakes. The opposite of B, because I'm not writing things. I should be writing A equals negative 1, B equals 1, and C equals 0. I should just be writing this stuff. Stop being lazy and not writing. The opposite of B over 2A, which is negative 1 over negative 2, which is 1/2. And then we have 1/2 squared is 1/4. Hello. Is 1/4. Minus 1/2. No. Okay. That's wrong. That's where I'm making my mistake. That's where I'm making my mistake. I mean, I'm very open in saying that we definitely make mistakes here. So that is negative 1/4 plus 2/4, which gives us 1/4. So we get 1/2, 1/4. So 1/2, 1/4. Okay. And now here's my y-intercepts are a half away. And now I get the point. This is the point. What did I plug in? I plugged in 1. My y-intercept is 0, so I should get 1, 0. Well, that says plus 1. Why did I do minus? Plus 1 is minus 1. 1 squared. Oh, baby. I am just making a mess of number 10. So thank you for being patient. The opposite of B over 2A, which is negative 1 over 2, which is 1/2. So 1/2 squared is 1/4. Bring the negative. 1/2. That makes negative 1/4. That makes 2/4, which makes 1/4. So 1/2, 1/4. 1/2 on the x, 1/4 on the y. 0. My y-intercept is 0, so its reflection point should be, if that's a half away, it should be, that should be 1, 0. Oh, hello. So I'm plugging in 1. Yes. Well, first of all, my additional point shouldn't be 1 because I've already plotted it. And I made a mistake with that. So we're not plotting 1. We're going to plot 2. So somewhere I should write what I'm plugging in also. So x equals 2. So we get negative 2 squared plus 2, which is negative 4 plus 2, which is negative 2. So I get the point 2, negative 2. 2, negative 2 makes sense. That is 1.5 away. So 1.5 the other way would be here. Those are my 5 points. And that took me 10 minutes. And just before this problem, I was saying, gosh, look how easy it is and how efficient and how much time you can save. Well, if you don't show your work and if you don't take your time, you're going to make silly mistakes with these fractional stuff. So case in point, why you should take your time, have a system. A equals negative 1. We know it's going to be upside down. And because we knew when it wasn't producing that, that helped me sort of know that I was making a mistake. C equals 2. So let's find the axis of symmetry. Let's go slow and methodical. Axis of sim. X equals the opposite of b over 2a. I like writing that. I don't know why I stopped. The opposite of b over 2 times a, which gives me 1 over negative 2. Part 2 is the vertex. That's taking my x equaling negative 1/2 and plugging it into the equation. The opposite of negative 1/2 squared minus negative 1/2 plus 2. And we get y equals negative 1/4 plus 1/2 plus 2. I know I'm correct because I'm taking my time this time. Let's find a denominator of 4. Negative 1/4 plus 2/4 plus 8/4 gives me a value of 9/4, which is 2 1/4. So when I plugged in negative 1/2, I got 2 1/4. Yes, feel good. Oh, yeah, my axis of symmetry is negative 1/2 for reals this time. I'm going to plot the point negative 1/2, positive 2 1/4, which is about there. My y-intercept is 2, so that's there. Its mirror point is there. Now I'm going to find an additional point by plugging in 1. So part 3 is additional point. And I'm going to plug in x equals 1. So y equals the opposite of 1 squared minus 1 plus 2. 1 squared is 1. And then we bring down the negative, negative 1 plus 2, which equals 0. So 1 gives me 0. That is 1.5 away. 1.5 away is this. Much better. Much better, Mr. McCausland. Congrats. All right, this has an A value of 1. And the reason why I got better was because I wrote out all of my work. C is negative 3. So I know it's going to be a U axis of symmetry. X equals the opposite of b over 2a. The opposite of b over 2 times 1, which is negative 1. Let's find the vertex. Vertex is going to be x equals negative 1, sorry. So y equals quantity negative 1 squared plus 2 times negative 1 minus 3. That is going to give me 1 minus 2 minus 3, which is negative 4. So my coordinate, my vertex, is going to be 1, negative 4. My axis of symmetry is negative 1. So let's draw that axis of symmetry. Let's do the point. The vertex is 1, negative 1, negative 1. That's a negative 1. Getting sloppy again. Negative 1. I plugged in a negative 1, just checking. Negative 1, negative 4. 1, 2, 3, 4. Good. My y-intercept is -3, which is 1 away, so I will do 1 away. And now I'm going to find an additional point. Let's plug in 1, because that just makes sense. Additional point. So where x equals 1, labeling and writing is always good. So 1 squared plus 2 times 1 minus 3 is 1 plus 2 minus 3 is 0. So that additional point is 1, 0. So 1, 0 is right there. It is 2 away from the axis of symmetry on the right, so it will be 2 away from the axis of symmetry on the left. And there's my parabola. Yes, love it. All right, so this is really important. This is just good for understanding how to graph parabolas relatively quickly. We will find other ways to graph them, but finding multiple points, this is a nice, efficient way when you do it correctly. So good luck.